is dividing whole numbers. So to divide whole numbers, we will use long division. Use long division. Okay, you can write the remainder. So when we get a remainder in long division, you can write it as a fraction. Have we done this before? The remainder as a fraction? Yeah. With what? How did you guys do it? Division? Oh. Okay. Okay, so write the remainder as a fraction or a mixed number. We'll talk about how to do that if we get remainders that are fractions or any remainders at all. Okay, let's talk about vocabulary. Okay, so the parts of a division problem have specific names. This is my long division sign. This is my little long division bar. The number that is inside the division bar, so inside the long division, the bigger number that's being divided by something is called the dividend. Okay, so it's important to know this vocabulary because the quizzes will use them, your homework will use them, and if you don't know, if it says, write the divisor and you don't know what that means, then check your notes. That's why we're going to put these in here. Good notes, good vocabulary. So the number underneath the long division sign is called the dividend. The number outside, so this is saying 300 divided by 15. The number we're dividing by is called the divisor. It is the number that divides, the divisor. Okay, so dividend inside, divisor outside. And what's the answer to a division problem? Odibo? No. Like, what do we call the answer to any division problem? It's called the... It's a vocabulary word. So the answer to addition is the sum. The answer to subtraction is the difference. The answer to multiplication is the product. What do you think? No. It is called the... No, that's addition. Quotient. The quotient is the answer to a division problem. So if you're ever told to find the quotient, you need to divide. Because the quotient is the answer to a division problem. Okay? All right, so that's just sort of vocabulary. How we would say this, you don't have to write this, but how we would say this long division or division problem as a sentence is 300 divided by 15 equals 20. Okay? 300, the inside number, divided by the outside number, gives us our quotient. Okay? All right, let's do some practice / review. All right, example 1 says 672 divided by 8. So we're going to set this up as long division. 672 is my dividend. That goes underneath my long division sign. And my divisor is 8. That goes outside my long division. Okay, then to find my quotient, I just start my long division process. Does 8 go into 6? No. So nothing's going to go here. Okay, you don't have to put an X, but just so that you recognize, I'm going to put that just so that we see how we're doing this. Okay, then we say, does 8 go into 67? Yes. How many times does 8 go into 67? Kenny? 8. 8 times. Okay, so 8 times. Make sure you put that 8 over the 7. Then we multiply. 8 times 8 is 64. And we subtract. Okay, 64 minus 67 leaves us with a 3. After we subtract, we bring down. And then we divide again. 8 goes into 32. Modibo. Very good. 8 times 4. 8 goes into 32 4 times. Do our multiplication. 4 times 8. And then subtract. 4 times 8 is 32. Subtract. When we end up with 0, we're done. So the answer to this problem, the quotient is always on top of the long division sign. The 0 means we have no remainder. So it went in evenly. Okay? Okay, let's do another one. Okay, this one's a little bit longer. This one's going to be a little more work, shall we say. Okay, inside our long division is going to be 92/16 because we're doing 92/16 divided by, meaning it goes underneath. It's being divided by something else. Okay, and it's being divided by 150, so that goes outside of our box there. Okay, then we start our long division process. Does 150 go into 9? No. Does 150 go into 92? No. So now we're all the way to 921. Does 150 go into 921? Yes. How many times? What do you think, Tate?
4.
Let's try 4. Let's try 4. Sometimes you have to guess and check. Let's try 4. So we're going to multiply. 4 times 0 is 0. 4 times 5 is 20. Carry the 2. 4 times 1 is 4 plus 2 is 6. This isn't going to be enough. What did I do? Okay, hold on. I just want to stop right here because you're not always going to guess the right number. We guessed, well, maybe it goes in about 4. When we did our multiplication and we subtracted, this number that we got is bigger than our divisor, meaning we need to go bigger up at the top. So I'm going to erase all this, and we're going to try a different one. I will call on someone by name who has his or her hand raised to tell me what it is. Don't just keep yelling it out. Modibo. 6. Let's try 6. What does it equal, Miles?
900.
Good. Okay, 6 times 0 is 0. 6 times 5 is 30. Carry the 3. 6 times 1 is 6 plus 3 is 9. Okay? And then we subtract. We end up with 21. This is good because this 21 is smaller than our divisor. That means we picked a good number up here because this number is smaller than our divisor. After we subtract, what's our next step? Mia?
Then you're going to just put 21 up because nothing else goes.
Nope. We still have another number up here.
Oh, 6.
We need to bring down that 6. Okay?
And then you add a 1 up top. Then you can go 1 top.
Very good. So then we ask ourselves, how many times does 150 go into 216? And Liam?
It goes into 1, and you'll get 66 once you do.
Okay, good. I'm going slower than that, but you are probably correct. It only goes in 1 time. 150 can only go into 216 once. So 1 times 150. We'll multiply that. And subtract. Okay? And then yes, what do we get? 66? 66. Okay? Now notice, in this problem, we ended up with 0. And that meant we had no remainder, so our answer is a whole number. Now in this case, we have a remainder. So we have to write our answer as a mixed number. Okay, 61 will be the whole number. of our mixed number. And the fraction is going to be the remainder, 66, over the divisor. The remainder will be the answer. You're going to write it as a fraction now. We don't just write, you may have done this in the past where you would just say R, right? You'd say 61, remainder 66. So this might be the new thing that we're learning today that maybe you haven't seen before, is writing the remainder. So whatever you have left after you've brought all the numbers down, you write the remainder over the divisor. Rather than saying R, we don't just say R, we write the remainder over the divisor as a fraction. Now, Eddie, question. This fraction, because it's not in simplest form, the whole number stays the same, 61 is fine, but we need to simplify this fraction. They're both divisible by 3, okay? Are they divisible by 6? They might both be. They're both divisible by 6, too. So let's go with that. The GCF, the greatest common factor, is going to be the fastest way to simplify. 66 divided by 6 is what? 11. And 150 divided by 6 is 25. 25. Now this is our simplest form. So I think the takeaway here is we need to practice writing our remainders as fractions rather than just saying R66. Write it as a fraction. You have? Great. Let's do a couple try-its. In your notes, please copy these and practice the long division.
6,000.
Yes. 6,096 will go inside, underneath the division, long division sign, and 30 is our divisor. It goes outside. So let's do the division here. Let you try it a little bit in your notes, and then I'll go over it in about 30 seconds, a minute. So, all right. Does 30 go into 6? No, not into 6, but does it go into 60? Yes. How many times? Twice. 2 times 30 is 60. Okay, we subtract, we get 0. Should I stop and say I have no remainder? No, why can't I stop here? Why can't I stop, Roger?
Because you didn't drop 96.
Good, we still have more numbers that I need to bring down. I'm not done with the problem. So I bring down my 9. After I bring down, can 30 go into 9? No, so what do I need to put up in my quotient, Liam? A 0. 30 can't go into 9. I subtracted, I brought down. And then I divided. Well, it can't go in, so I have to put a 0 up here saying 30 does not go in to 9. Just like we would do with anything else. If it went in, if it was a bigger number, we'd put that number up in the quotient. Well, that's our next step. That's our next step. Do you guys see, does 30 go into 9? Okay, I'm going to back up for 1 second. We did this. Are you all with me on this part? 2 times 30 is 60. We subtract. Subtract, 0. Bring down, 9. After we subtract and bring down, we have to ask ourselves the division question. Subtract, bring down, divide. Does 30 go into 9? No. So we have to put a 0 up here to say it does not go in. Then what do we do? Roger?
You bring down the 6.
Now we bring down the 6. How many times does 30 go into 96? 3 times. 3 times 30 is 90. And look what we end up with, a remainder. We are not going to write this as R6 Instead, we're going to write it as a fraction. And what would my fraction be? What's my fraction going to be? Colin?
236.
Yes. 6, the remainder, over the divisor. Okay? But, Kennedy.
You have to simplify it.
Yes.
And then it would be 203 and 1/5.
Good. 6/30 is not in simplest form. They're both divisible by, Luke?
3.
Bigger. 6. 6. They're both divisible by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. So our answer is 203, bless you, and 1/5. Okay? Perfect.
And you would get 150.
Okay, you're a step ahead of me. You are correct. So in order to figure this out, we have, you're going to pay total $13.80. But instead of paying it at once, you're going to pay it over 12 payments. So you're going to divide. Exactly. $13.80. And we're going to divide that by 12. Okay? Because if we divide into 12, it's going to tell us what is each payment valued at. So now we do our long division. 12 does not go into 1. 12 goes into 13 one time. 1 times 12 is 12. Subtract, bring down, divide. 12 goes into 18 one time. 1 times 12 is 12. Subtract, bring down, divide. 12 goes into 60 5 times. 5 times 12 is 60. So I end up with no remainder. How much is each payment? Luke? $115. Don't forget to label the answers to your word problems. Okay? All right, let's see what's on the next page. Let's look at this one. Again, you don't need to write all the words, but let's just figure out how we would solve this. All right, here's an amusement park swing. You know those things that like have all the swings and then it spins around like.
And also, yeah, it's like it's really hard.
They're actually
The ones that are so high up.
Okay, an amusement park swing can hold 64 people per ride. So 64 people can be on it at one time. Okay? It says 10,250 people rode the ride today. Total. So it goes over and over again. You know how these things are. People get in line, they go up and they do the ride, and then so in total, from the start to the end of the day, 10,250 people rode. How many rides were given? So if it was full and there were 64 people every time the thing ran, how many rides were given? How many rides, how many times did it go? How would we solve this? How are we going to set this up? Luke, what would you do?
64 divided by.
Which one which one's being divided by? Yes. Very good. 10,250. That's the total number of people divided by 64 each ride. And then it's going to tell us how many times the ride ran. Like how many times did it go? All right, so let's do our division. Ooh, is that too big? Does it only go in once?
Yeah.
Oopsies. Subtract, bring down. So what? 6 times 5. Has anyone done it? Okay, let's be doing this. As I'm doing it, you should be doing it.
Can we just call down for you?
Well, kind of, but then I have to do all the working and the thinking, and it's good for you to also be working and thinking.
But what if you really honestly don't understand?
All right, so let's try 5. It's 6? Thank you. 6 times 4 is 24. 6 times 6, 36. 6 times, yeah. Oh, yeah, 1. Shh. Which is 1 and bring down. Does 64 go into 10? No. And then we can't do anything else. We have a remainder of, what's our remainder? 10. 10. So now think about this question. How many total rides were given if 10,250 people rode? Think about it. What do you think, Roger?
164.
Close. What do you think, Sam?
161.
161. You are correct. Very good. Look at this, you guys. We know that there were how many full rides that had 64 people total? We had 160 rides that were completely full. But what does this 10 represent? 10 more people that also rode the ride. It just wasn't full. Right? But we were told that there were 10,250 people that rode. So there was 160 rides that were full, 64 people. And then there was one last ride, maybe at the very end, and it only had 10 people. That's our remainder. Does that make sense? So technically there were 161 rides, but they weren't all full because one only had 10 people. But it had to still be a ride, right? Just not full. Does that make sense? Just not full. Yeah, you got it. Okay.